Right, so today we are going to be watching flat earthers versus scientists. They're going to be debating whether or not we can trust the science on Jubilee's middle ground. And hopefully, just like in the Find the Flat Earther video, we can have a bit of a laugh and add some interesting science along the way. So let's just jump straight into it.
The one on my right, sphere, if you think that is the shape of the Earth, point to it now. If you think the other model is the shape of the Earth, point to it now.
2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
One small step for man, one giant leap for mankind.
Oh, what an intro.
Think the shape of the Earth is.
I don't think. I know for a fact it's a globe.
That's one thing that loads of people flagged in their last video. A lot of people didn't like that they said, I believe the Earth is round and I believe the Earth is flat. Kind of appropriately, because facts are true regardless of whether or not you believe in them. But then again, philosophically, other than knowing that you exist, arguably all knowledge is just belief. Just some of it is really, really close to being certain. But I fear this is getting too pedantic too soon. So let's continue.
The Earth is flat.
It's like we have this picture of reality that's a big puzzle piece. And then one of those pieces just wasn't fitting.
Wasn't fitting according to the experts, or wasn't fitting to you? Because there's a big difference between leading scientists in the field being like, this doesn't make sense, therefore our theory might be wrong or have holes in it, and you, a layman, saying this doesn't make sense to me, therefore it can't be true. Because the latter is just the personal incredulity fallacy, which unsurprisingly is a fallacy committed a lot by flat earthers.
I'm always open to having a discussion with someone who is holding a wrong belief like this.
Are you willing to change your mind on this?
I'm not. The evidence is so much.
That's a slightly surprising response from a scientist. I think one of the most exciting things about science is that it's always there to be proven wrong. There's a respectable humbleness about science that says, no matter how much evidence we have, or no matter how certain we are that something is true, it can always be proven wrong with sufficient evidence. Though having said that, I don't think that scientist was sitting there going, in the face of overwhelming, compelling evidence, I still wouldn't change my mind. I think he's going, there's so much evidence that the Earth is a sphere, and it's so overwhelming and so compelling that I don't genuinely think that there is any chance realistically of sufficient evidence to the contrary being presented.
Nobody wants to be a flat earther, but if you showed me incontrovertible evidence, I would definitely go back. Who wants the ridicule?
What are you hoping to get from the discussion with the other side?
I'd like to tear them to pieces.
That is another thing that a couple of people flagged in the last video, that some flat earthers don't hold their beliefs because of overwhelming compelling evidence, but because they like deviating from the norm and being unique and being special and having this desire to be like, I know something you don't and I'm better than you because of it. And of course not all of them are like that, but that is a strong indication that he is. It is actually just so nuts, isn't it, that in the modern day, we are having a debate like this. It really is one where if you don't laugh, you'll cry.
I'm Jim Underdown, Executive Director of the Center for Inquiry West in Los Angeles and the chair of the CFI Investigations Group.
I'm Spencer Marks, one of the senior members of the CFI Investigations Group, Science Advocate.
I am Marlene Yeri. I'm a theoretical physicist, and I'm with the University of Irvine.
I'm Wendell Walton. I'm a Chief Learning Officer for a young startup.
I'm Shelley Lewis. I'm a graduate of West Point, critical thinker, and jumped out of airplanes.
Quite telling that on the side of the scientists, they have like executive directors and theoretical physicists. And on the side of the flat earthers, they're like, I'm a critical thinker. It's like, okay, they've sent their best here.
My name is Dan Glattman. I work as Dan the Waterman in the drinking water filtration industry, and I'm a truth seeker.
I get my flat earthers on the left and my globe earthers on the right. Only step forward if this is true for you. I believe the Earth was created by a higher power.
Well, I've been a Christian for 30 years, so the Bible is a flat earth book. You have to take it literally. Like, for example, in Isaiah, when it talks about how the earth is like a clay wax seal that's stamped with upturned edges, that's just not some fancy story. That's a simile. it is like.
This is so interesting. We spoke about this in the Find the Flat Earther video. One of the people I was trying to figure out who the Flat Earther was amongst them asked who was religious. And we went through a couple of the Bible passages that, when read literally, can be interpreted to suggest that the earth is flat. I mean, he took a quote from the book of Job and attributed it to the book of Isaiah, but close enough.
And in Isaiah talks about too, and I'm a Christian, he who sits upon the circle of the earth. There's a difference between a circle and a ball.
That's one of the passages from last video.
Well, exactly.
Yeah.
If you look at the original Hebrew, it means disc. There's over 200 scriptures in the Bible that point to a flat earth.
That is perhaps less a case for flat earth and more against biblical literalism.
So this notion that you need God or some higher power to create the earth or the universe is very old and was initially posited by people of a pre-scientific age. Since then, we have learned quite a bit about the universe coming into existence, when that happened. Modern humans don't get their cosmology, they don't get their physics, they don't get their knowledge of the universe from the Bible or any ancient text.
It's sort of like the God of the gaps. Once, people used to believe that lightning was God's wrath and throwing these lightning bolts, but once we understood it was a natural process, God shrank a little bit more because now we couldn't attribute those lightning bolts to God. We had to attribute that to the real science. And the other thing, the point about the Bible specifically for me is, why is that one particular text the correct one? You choose to believe that, and that's fine, but there's so many other writings and so many other books, so why weren't they correct? Why is just the Bible correct?
That is an interesting question, but more of a theological one. Is Christianity true is an interesting debate topic, but it's not what we're here to discuss. I feel like a more interesting question would have been, how do you know that this is the correct interpretation of your scripture? Because then you're not asking someone to abandon their entire religion. You're just saying, okay, you believe God created the earth, this is the shape of earth according to all evidence we have. And so the only reasonable way to reconcile those two is to take a different interpretation of your scripture. If you're trying to get them to change their mind on this, that to me at least seems a far more fair and realistic way to go about it, compared with calling into question their entire metaphysical worldview.
Well, what you'll find in a lot of these ancient religions is they're all flat earth religions. All their cosmology goes back to being a flat earth with an enclosed system. So it's not just the Bible that teaches this, it's many different religious books.
I mean, is that surprising? That back in the days when they were far more concerned with survival than science, they didn't really know the shape of the earth? I mean, if you don't think about it too hard, the world generally looks flat in everyday life, and there's no obvious curvature to the naked eye. I mean, before advances in mathematical reasoning and physics and cosmology, of course a lot of people will have thought that the earth was flat. Now that we've got the tools to measure otherwise, we've realized that some of our ancestors were wrong, not for the first time. That's how science works.
So one problem I have is to trying to explain phenomena happen in nature by holy books. Those are religious books. Those are not books of science. And it is wrong to infer or deduct scientific readings out of those books.
And I don't think their purpose ever was to be scientific textbooks, so I don't really know why people insist on treating them like that.
My name is Wendell. I am a logical, biblically based, and scientific flat earther. I didn't start out, and no one starts out as a flat earther, but I had a lot of questions. So I actually got to the point where I had to go out and put my own eyeballs on it. So we went out to an observation at Salton Sea, and things just didn't add up down there. So we've gone back probably a dozen times. And I can guarantee you that there is no curvature over distance.
Interesting. Well, if you're doing the experiments, publish it in a peer-reviewed journal. Let scientists critique your methods. Maybe you're doing something wrong. Maybe you're getting a calculation wrong. But maybe you're right. Other scientists can replicate your results, and you will have done something. Oh, I just wanted to add, by the way, I spoke about the laser experiment in the movie Beyond the Curve in the last Flat Earth video. And obviously I mentioned that the results confirmed that there was curvature over the water. But people interestingly noted that Jeranism, one of the guys that conducted that experiment, is no longer a flat earther. That is partly because he witnessed a 24-hour sun in Antarctica, which a lot of flat earthers don't believe exists. But it's cool to see flat earthers stick to scientific principles and go, I had a hypothesis, I tested it, the results didn't confirm it, and so I no longer believe it. So fair play to him. Maybe Wendell will follow in his footsteps one day.
The internet has played an important role in confirming my view of this topic.
That's the problem.
Oh, maybe our parents were right. It's the damn internet. It actually is. It's just the way the algorithm works. You get into a bit of an echo chamber, you know, maybe you start exploring flat earth videos and bam, it becomes your entire timeline because the algorithm knows that that's what you're clicking on, that's what you're watching, that's what you want to see. And humans love confirmation bias. If you get a video being like, you know what, your worldview is correct, it gives you that certainty, it reduces anxiety, it gives you that emotional comfort. And also it's key to social cohesion. If you're lonely or isolated and all of a sudden you develop this community that you can feel a part of, where you can feel special and bond with these people over this shared idea, of course people are going to keep seeking out and consuming this information. And of course you want to keep those feelings, so you're going to be more likely to ignore or discard any evidence that proves you wrong.
Well, we have the advantage of information today that's outside of channels 2, 4, and 7 and the few networks that are corporately owned. It's pretty easy to say YouTube isn't research, but when you spend enough time, you're picking up quite a bit. And with the discussion groups, panels, we've gone against opposition, we've opposed ourselves. Surprisingly enough, flat Earth is its own worst enemy.
You can say that again.
So it's not that easy for us to come to consensus. And we find that consensus is orchestrated and not actually scientific in any way.
Again, just, yeah, that's a big problem with flat Earth. Like, because the Earth is a sphere and that model accounts for everything we observe and measure in reality, the same cannot be true of a flat Earth model. So they'll come up with a model and set it up in a way that satisfies a certain number of observations, but makes the results of other observations impossible in that model. Because it's inherently inaccurate. Whenever you gain accuracy in a certain measurement, you lose it in another. Just like we see with trying to create 2D maps. So they are just constantly fighting and they can never ever agree on one unified model, which in turn kind of makes it harder to critique, because you can turn around to a flat earther and be like, this model like doesn't account for this, like this doesn't make sense on that model, and they'll just go, oh well, I don't believe in that model. And when you ask, okay, what model do you believe in, they cannot present one. And I kind of wish people would speak about that issue more.
You know, my grandfather used to tell me growing up, never believe anything you read in the newspaper, right? He told that to me. Now, with the age of the internet, it's like, you know, how much of this misinformation are you getting there?
Oh, it's crazy. They're so close. Correct. How much misinformation are you being fed? The news and the media and the government and academia and science are all saying this one thing, and these YouTubers are saying another. If you're going to be skeptical, that's great. Be skeptical of all of them and then go about it the right way. Ask yourself, how can I figure out and determine who is right? And that is how to properly be skeptical and find the pathway to truth. Because being skeptical isn't just, everyone's telling me this, everyone thinks this, therefore I'm going to disagree with it and think the opposite. And this is the entire point.
And when you have like eyewitnesses taking video of something, you do have to take everything with a grain of salt. That's why, because of my my multimedia background, I knew that all that stuff could be faked. You know, take it into Photoshop, take it into After Effects.
Okay, this is at the core of the issue of why there are so many flat earth believers out there right now. The problem is the information from someone who decides to start a website or produce a YouTube video is not reliable. When I have a toothache, I go to a dentist. When my car breaks down, I go to a mechanic. When you have questions about cosmology, you should go to an astrophysicist, you should go to a physicist, you should go to people who have spent years and years studying these ideas, not some 6-minute YouTube video. There is a percentage of people that if they saw a YouTube video that was not within their scientific chops to refute on the face of it, would believe anything out there.
Yeah, fair enough. Well said. Although that being said, there is a lot of good educational content on YouTube. For every Flat Earth channel, there's a Simon Dan, a Professor Dave, a Gutsick Gibbon, and a Forrest Valkai just waiting to educate them and correct their mistakes. And in my opinion, at least, they do so very entertainingly, and they are a big part of the inspiration behind me doing these types of videos.
One of the things I will say is NASA.gov has their own documents out there that we get to vet, which is through the Freedom of Information Act. And would you agree that NASA documents, if they're on display, that we should be able to go and research inside there?
NASA is not proving that the Earth is flat.
Well, they say it in 14 of the documents.
You should read what NASA says, and you should listen to what NASA says.
I would love to see your NASA evidence that the Earth is flat.
It's only their contradictory issues that bring us here.
Okay, this is why I like doing these videos, because I have the privilege of being able to pause, pull something up that they're referencing and address it properly. Because here the scientists are going like, I'm sure you're wrong, but I have no idea what you're talking about, so let's move on. So here's an example of one of the documents that the flat earthers were referencing. NASA reference publication 1207, derivation and definition of a linear aircraft model 1988. And it says, in the concluding remarks, this report derives and defines a set of linearized system matrices for a rigid aircraft of constant mass flying in a stationary atmosphere over a flat, non-rotating Earth. But you know what they say about models? All models are wrong, some are useful. Sometimes in models you simplify assumptions to simplify calculations. I mean, look, it says rigid aircraft of constant mass. Aircraft burn fuel and therefore get lighter as they travel. Also, a stationary atmosphere. Our atmosphere isn't stationary. There's wind and pressure differences and so on. And of course, the Earth isn't flat and it's not non-rotating. But for the scale of the model, the differences are likely to be so insignificant that they're just not relevant. Whatever the model's trying to achieve doesn't need to factor in these tiny, minuscule differences that would be caused by factoring in the mass of the aircraft, the changes in atmosphere, and the fact that the Earth is curved and rotating. Also, unless high speeds or long distances are being calculated, the default when you're doing flight dynamics is having the Earth as a fixed reference frame. So these documents aren't NASA going, oh, by the way, the Earth is actually flat and stationary, and our calculations only make sense under that assumption. They're going like, for the purposes of these calculations and models, there is no need to factor in the curvature of the Earth. We can simplify our assumptions because the effect on the outcome is so minuscule that it's just not relevant. It's nowhere near significant enough to make complicating the calculations to match reality more accurately worth it. The model does what we want it to do without the added complexity. But like I said, the scientists have no idea what they're referencing there. They don't know what they're getting at, so they can't answer them there, and I don't blame them. Thank goodness for YouTube, am I right, guys? Just quickly, by the way, whilst we're on the topic, if you're enjoying this video, please feel free to subscribe down below if you want to see more content like this. I would absolutely love to do more videos like this because I absolutely adore doing them, and it seems like you guys really enjoy watching them. Subscribing on this video is definitely the best way to let me know, but if you're already subscribed, just hit the like button. And whether you were already subscribed or you just subscribed now, thank you very much. I really appreciate it. Okay, on with the video.
We're all familiar with the Earthrise photo, right? The Earth is rising over the moon. We're all familiar with it. That's NASA. You can go out to NASA's site. You can download the original, right?
I already know what you're going to ask.
So you bring up the luminance on it, and you can see where it's cut out and pasted there.
They're showing us doctored images that are clearly doctored.
All right, so once again, the scientists don't really know what the flat earthers are talking about here, so they just don't address it and they move on. So here is Earthrise taken by Bill Anders on Apollo 8. This is what Wendell was talking about. And here, so I've brought it into Photoshop. Let's do this together. Let's open up Camera Raw and let's turn the exposure up. And this is essentially what the flat earthers are talking about. This box around Earth. But I mean, if that's the first thing you notice, surely the second thing you notice is the exact same boxy pixelation happening all around the photo. It's happening to the moon as well. And if you're curious why that's happening, Dazza the cameraman has uploaded this video, Rob Skiba faked NASA photo debunked, where he essentially spends about 10-15 minutes walking you through compression of photos. If you don't want to watch the whole video, here's an example that he brought up that I really like. A photo of a European wildcat with the compression rate and associated losses decreasing from left to right. And there you can see the exact same kind of like boxy pixelation. He illustrates essentially the same point on different photos from NASA. But yeah, in essence, it's not Photoshop. That's just how compression works when you're saving photos. I will say there's one other image that goes around flat earth circles a lot that he might be talking about too here. And it's this one. And there is definitely a black box around the Earth here. But unsurprisingly, this photo is nowhere to be found on NASA websites. This goes around the conspiracy theory groups being like, oh, look at this. This is NASA obviously trying to deceive us. We can tell it's Photoshop. It is Photoshop, but it's not from NASA. So there, now you know.
They're showing us doctored images that are clearly doctored. The blue marble is a very famous image from 1972.
Great image.
When you talk to the artist from NASA, his name is Robert Simmons, he talks about exactly how it was created from data, and it's not a photograph whatsoever. He added clouds.
Let me explain.
He added a highlight of the sun.
If you take, you know, on your phone, most phones have that panoramic image. When you do that, you're taking a series of pictures, and the phone cleverly stitches that together.
I'm just saying how it's presented. It's presented as a real photograph.
So when NASA takes real photos and they either clean them up for color or they stitch them together so it's one large image, it doesn't mean they're CGI.
You're talking about composites.
Yeah, that panoramic shot is a great example. If you took one of those, I don't think a flat earther would say that's not a real photo, just because it's a series of photos that have been digitally stitched together. But anyway, even when we do have single shot photos of Earth that aren't composite images, flat earthers still deny that they're real. Case in point, Earthrise that we spoke about just before this. Sometimes when the goalposts keep getting shifted, there's just no scoring.
Yeah, I'm what you call a globe denier. You could even get me into a virtual construct if I can't find the borders myself.
What shape would you say you think the Earth is?
It appears to me to be a stationary plane, as opposed to the vastness of infinity of space. I would find it to be an ice plane where we have a localized sun and our environment thrives there. You know, these particular people have misled us on television. This is a brilliant opportunity to speak. We've been suppressed, censored by mainstream media. Alternative media is just a thing of beauty for me.
Yeah, it's a blessing because it's very entertaining hearing about all this kind of stuff, but it's also a curse because some of these people go down these rabbit holes and never come up for air again. At least Flat Earth isn't a harmful conspiracy to believe in, although it is a bit of a gateway one.
I view the other side as uneducated.
I'm running.
They think we are
I'm
uneducated.
running for this.
Well, they certainly think they're educated.
And they're following quite a bit of the university system, what we call scientism.
Right, scientism.
Such an irritating word for people to use. The suffix ism is borrowed from the Greek ismos and the Latin ismus, and it essentially means a doctrine, a set of principles, an ideology. And calling science scientism is an attempt to degrade science into this set of ideas and principles that just must be rigidly followed, you know, whatever science says you must agree with. Whatever the leaders in science, the leading scientists say, you must follow, you must accept, because that is dogma. There's an authority and whatever ideas or principles or whatever are laid down must be true, and you can't argue against them. But science throughout history has been a story of challenging the status quo. Big ideas in science were almost always met with a lot of resistance, but because we were able to test and investigate and observe and do science, we were able to say, actually, this lines up with what we observe, what we measure. There is an overwhelming amount of evidence to suggest that this is true, so we should probably accept it. But pseudoscientists like this love to come along and go, this is what is the established science, I disagree with it, and because I disagree with it, they're all constantly saying, I'm wrong, I have to accept that this is the shape of the Earth. But they're not doing it because it's dogma. They're not doing it because some authority has said the Earth is a sphere, therefore everyone must accept this. They're going like, the overwhelming amount of evidence says that the Earth is a sphere. We're saying you're wrong because of the evidence, not because someone is telling us to say that you're wrong.
Right, scientism.
Obviously is the belief in what's written, where we tend to be exploring in the field with physical properties.
Like, what do you think that scientists are doing all day? They aren't just reading and writing books and saying, this is what we believe now, this is what we believe now. They're out in the field experimenting. Open up a peer-reviewed scientific journal. It is filled with people constantly doing experiments. Everyone is constantly going, oh, these are the experiments that have been published recently. Let's do it ourselves. Let's see if we can prove them wrong. The arrogance of a flat earther to think that they're the only ones out in the field conducting experiments is laughable. And if you watch any of the flat earth experiments on YouTube, they either do the experiment right and the results are exactly what you would expect on a curved earth, just like in the Beyond the Curve documentary film, or you can quite clearly see something they've gotten wrong in their methodology or in their calculations. But it is just the Dunning-Kruger effect in action.
With physical properties, not theories of any kind. We're using actual measurements that are calculated not by our guidelines, but the guidelines of science as we know it. I can only hope they're uneducated as opposed to disingenuous.
Well, that's the other thing too, because we know that at least on a large scale, the government has been disingenuous, and they're pushing a narrative, right? So it's hard for us. I mean, I'm sure that you've met people too. It's like, look, are you haven't looked into it yet, or are you a shill? Are you part of a disinformation campaign?
I think it's just so telling of the mindsets of the two groups that the flat earthers are the ones sitting there going, they're uneducated. And I bet the scientists are going to sit down and be like, we don't think you're uneducated. We just think you've been misinformed. Maybe you have been educated, but by someone who was wrong.
I don't think you guys are uneducated. I think you're wrongly educated.
I think the problem with...
He literally said exactly a perfect summary of exactly what I thought they were going to say. And it's something a couple of people were surprised to hear me say in the last video, and I was like, a lot of flat earthers do actually know quite a lot of the science. There are a fair amount of flat earthers that have a fair amount of knowledge. They can name and describe the Apollo missions. They can talk about the astronauts. They know the names of all the photos taken from outer space. They know about and can name a lot of the big satellites. They know a lot about the history of NASA and space exploration. But again, like I said, there just is ignorance in there somewhere. There's either something they don't know or don't understand or misunderstand, and that's why they're a flat earther.
I think the problem with what I've seen in the flat earth crowd is that it's not that they're undereducated, but they, instead of looking at evidence and letting the evidence guide to where the ultimate conclusion is, they start with a conclusion and then they try to cherry pick evidence to support their pre-drawn conclusion. They cast away all the bits of evidence that actually is contrary to their belief system.
I think that you're very well educated as well as you are, Jim.
And certainly Ali is. He's probably get the best education of all of us.
Exactly, and he paid for it too.
Right, so why did he sit down when they said sit down if you think the other side are uneducated?
But more and more professionals are coming on board. They're starting to question their reality. So the thing of it is once you start to really take a hard look at the evidence, and you are unafraid of just standing for the truth wherever that may lead you, then people end up becoming flat earthers.
What are we hoping to get from the discussion today?
I'm hoping to be able to tell our side of the story from the inside out. So many times, flat earthers are depicted from the outside in, and I want to be able to share with others empirical data that proves the earth is not what we've been told.
Okay, that's what I'm looking forward to. Interesting that she's not got on there being like, I want to find out if I'm right. You know, I want to put forward some ideas and ask some questions and see if there are answers or see if there aren't. But of course, she's not there to have her mind changed. She's there to represent the flat earthers. But hey, if she's got some empirical data, I'm looking forward to hearing it.
I have changed my mind at some point about this topic.
So when I was 12 years old, I went to space camp and I met Alan B. Shepard.
Oh, nice.
Yep. And I wanted to be an astronaut and I wanted to be the first woman to walk the moon.
Oh.
So for me, I'm a glober.
Oh, this is actually kind of sad. Like the two pathways of like, could have been an astronaut is now a flat earther. I mean, there are darker paths in life to take, but still, that dichotomy is a bit depressing.
I went into this completely wanting it to be true. And my husband told me, you know, he saw this thing about the fake moon landing. And I was like, you're absolutely crazy. There's no way that the moon landings are fake. And then in 2010, my husband was killed. And so I never really developed that until around 2014 when Flat Earth kind of came back up. And that little voice inside my head said, remember the fake moon landings? Remember when that was brought to my attention? And then I started really critically analyzing that. And I would say, you know, just looking at that evidence, if they can lie about the moon landings, they can certainly lie about pictures and satellites and other things. And so I started going down that rabbit hole of studying. So that was my influence from my husband.
How many lies does it take to make a liar, right?
And being ridiculed for being inquisitive is pretty tough on us.
Yeah, that is the one tough thing. Like the natural scientific tendency to go, oh, here's what everyone believes, let's challenge that. Some of the greatest scientists of all time have had that exact mindset. So it kind of does suck when you see people clowning on people for being inquisitive and going like, you know what, I'm gonna call into question everything I've been told to believe. I think the criticism should be reserved for the way that these people go about it. You know, like saying, oh, you've just turned around and gone, you don't want to believe the government, so you're believing essentially the opposite because this other smaller group is saying it. Or like, okay, you've gone out and conducted your experiment, but you've done it wrong. Or there's a massive calculation flaw here. The issue isn't that you're inquisitive. The issue is with your methodology that you used to conclude that the status quo was wrong.
I wouldn't say that I've changed my mind because my mind isn't set. NASA is solely designed to change my mind. It is, from its inception, from its discovery, has been a television program, it's been a space program to sell us on something that they've yet to actually show us. Show me a globe spinning with clouds and a moon, show me home, and I think I could shut up quite I mean, easily. I think I could shut up.
Well, to be fair, we're probably only a few years away from commercialized space travel for the regular Joe. So it is going to be super interesting when these flat earthers go into outer space and look down at Earth and the moon and go, oh damn, they were right. All right, guys, you can bring me back down to Earth now. Guys? Also, just because he brought up that he thinks that NASA's sole purpose is to lie to us about the shape of the Earth, I think it's important to say that, okay, space exploration is great and scientific discovery is really cool, but so much of the technological development and Earth observation helps us in our everyday lives and makes it undeniably better. I mean, along with the satellites that help with communication and navigation, a lot of technology that was developed for space found its way into our everyday lives, like scratch-resistant lenses, cordless power tools, memory foam mattresses, artificial limbs, laser eye surgery, MRI machines, even the tiny high-quality cameras that are inside your laptops and phones, maybe even the devices you're watching this on, were pioneered for NASA spacecraft. And that's not to mention all the benefits of being able to observe Earth from outer space and monitor the climate, weather, natural disasters, and so on. And potentially most importantly, it could be the reason that humans continue as a species. A lot of people think that going interplanetary is the only way to ensure the survival of the human race. So yeah, there's a lot more to it than just selling the globe.
The timing of your conversions is interesting to me. 20 years ago, the flat Earth world was tiny and insignificant. Enter the advent of the internet, YouTube, online discussion groups, all these new available places where you could find information about everything.
This is true that the evidence as you looked were not robust evidence. And the sources you used, they were not reliable sources again. But my problem is that, and I like you guys that you are very skeptical, but at the same time, you are not skeptical about your belief system.
You
that
keep
should
going
have come
back.
first.
You think that that's my foundation for why I believe the Earth is flat, and I'm telling you, you're wrong.
Okay.
I have evidence that proves it's flat.
What type of
proves
evidence?
It's not a ball.
What type of
Curvature,
We're being misled. We're being deliberately misled by mainstream
Now,
media.
what's your evidence you're
We
thinking?
see too far. We see too far. We should not be able to see. I live in Dana Point.
Okay.
I can see San Clemente Island, which is 60 miles away.
So
But
what?
it's very high.
What do you mean, so what?
No, I'm
It's
on the
1,100
beach. I'm
feet
on the
tall.
beach.
It is
What do you mean by
tall.
so what?
I'm on the
But-
beach.
Yeah, yeah.
Can you see a ship which is going?
We're
Oh
not
yeah,
talking
let's talk
that.
about the ship that goes
Yes,
over the curvature
okay.
of the Earth. I love
So-
that. So science has said that when I see a ship go out of my field of view, it's going over the curvature of the Earth, correct?
Yes.
But then I bring my P900 up, and guess what? I can zoom it back in.
Not
So
all
is
the
it
time.
going over the curvature of the
No,
Earth
you
or
can't.
not?
You don't see all
Absolutely.
Oh,
of
not
it.
all the
you
time?
Oh, flat earthers love the P900. It's because it's got an 83 times optical zoom. And so they see things on the horizon that disappear to them, they can't see them anymore, and then they zoom them back into frame with a P900. But unfortunately, no level of zoom is bringing the bottom of this ship back into view. Obviously, atmospheric refraction can bend light, so some objects can seem higher than they should be. So sometimes things are visible farther than expected. But yeah, P900, it's not a miracle worker. No matter how much you zoom on that camera, you are not seeing the bottom of that boat. And again, like the island thing, like if you took her eye level, the sea level, the distance to the island, and you did all the calculations, I bet whatever she's seeing is exactly what you should see if the Earth was curved. Like so common in these flat Earth experiments is that their eye level isn't the same as sea level. Also, they'll see the top half of the island and be like, I shouldn't be able to see it, whereas only the bottom half should be covered by curvature. And I mean, even if she was factoring everything in, how much do we trust her calculations here? Have we got any good reason to think that she's reliable there? I don't think so. But yeah, she should set it up. Take her camera, show what she can see, show her workings out, and then, you know, let us be the judge. But just sitting there going, I have evidence, and when someone asks for it, going like, I can see things beyond the horizon that I shouldn't, it's not good enough. That evidence is not strong enough to change any reasonable and logical person's mind.
The bottom part of the ship
Yes.
is hidden by the
At that
curvature.
distance, you shouldn't see the top
At
of it
all.
either.
If the Earth were truly flat, there would be really hardly any limit. You would be able to stand at the top of the Empire State Building and look towards Chicago, a mere 1,000 miles away, and see the lights of Chicago at night.
No,
Why wouldn't
no, because you have an atmospheric disturbance.
Very thick.
I've been
Water
into
alone.
astronomy since I was 10.
It's faulty logic. It's completely faulty logic.
Let's reset, and then I have a more interesting.
Okay.
One of the big things I do is investigate extraordinary claims like flat eartherism or ESP or all sorts of different things.
ESP, by the way, is extrasensory perception. It's essentially the supposed ability to gain information without using your senses. So things like telepathy, clairvoyance, future telling, that kind of thing.
The Earth is undoubtedly a globe and not flat. This is well supported by gobs of science.
Scientific consensus is possible.
Scientific consensus is possible.
What is the question?
I don't understand the question.
Scientific consensus is possible.
Possible. Anything is possible. I mean, anything is possible. I've got a tremendous issue with consensus and peer review.
The flat earthers, by the way, taking a long time to figure out what the question means is a little bit funny.
I've been spending a lot of time arguing with people that argue the other side. And I found that surprisingly, consensus always wins. It was shocking to me that the group with the majority has an incredible advantage. As scientists, flat earthers, truthers, punks, we're at an incredible disadvantage.
Let's talk about scientific consensus for a second. You're never going to get 100% of anyone. There is scientific consensus on a global Earth. There's scientific consensus on evolution. A lot of big issues.
Use the word theory.
No, do you know what a theory in science is? An extremely...
And a fact is a fact.
Don't mistake this word theory.
You are.
In science, it's not conjecture, it's not...
It's an explanation. By definition, it's an explanation.
It's a deep...
Well, let's talk about a fact. Show me a fact
made a
then.
mistake.
Why
They
aren't
think
all
theory
facts
is-
theories?
In science, the word theory is the highest level that you can give something because it's so well supported.
What about a fact?
That is a fact. It's
not a fact. You would call it a fact.
You know why? Do you know why? Because in science, there's always room for improvement. There's always room to find to tweak and find better information.
So that is how science works.
It gets better refined over time, as opposed to flat earth theory, which never gets refined.
This, I think, is probably the biggest tell for someone who is not very well versed scientifically. Someone who thinks that a scientific theory is considered just a theory because it hasn't amassed enough evidence yet in support of it for it to be considered a fact yet, just hasn't spent enough time at all engaging with science. People in normal conversation use the word theory like hypothesis, like, oh, I have an idea, I haven't explored it yet, but I have an idea, I have a theory. But in science, a theory is a well-tested explanatory framework. So like germ theory of disease explains how microbes spread and cause disease. That's a fact. That explanatory framework isn't just a guess. There isn't not enough information or evidence yet for it to be considered a fact. That is how microbes spread, and that is how they cause disease. It's the same with atomic theory, the theory of evolution, as they said, plate tectonics, cell theory. Again, it's a bit like the no models are correct, but some models are useful. But like we can be so certain that these explanatory frameworks accurately represent what's going on, that we can essentially consider them facts. But people who don't understand that go, oh, well, you called it just a theory, so you can't be sure. If you were sure, you'd call it a fact or a law. But they don't understand that a scientific law is a description of what happens, and a theory is why. A scientific theory isn't upgraded to a scientific law when it has enough evidence. They're completely different things with completely different purposes. And so Dan has just shown here that he just doesn't know what he's talking about, and it's so frustrating, especially when he's so insistent that he's right.
New ideas have limited access to media and limited exposure. Until we're in university curriculums, we will continue to appear uneducated.
Well, that's not true.
But it's not arbitrary what makes it into university curriculums. You don't just present a new idea and some of them become a part of the curriculum and some of them don't. When you present an idea, you need to have enough evidence. And if you have enough evidence for it to be compelling and other scientists can recreate your results from the exact same experiment, and it's been tested and repeated over and over again and it's reliable, that's when the field will accept it and go, you know what, it's reasonable for us to accept this.
In the history of science, we had many occasions that the idea it was not welcomed by the society. Einstein was one of them. Galileo was one of them. But if your theory is an authentic one, and it can go through this hardship of scientific method, eventually will win.
I used to believe that science was after the truth, right? We all just want to know what the truth is. Science has been trying so hard to divorce itself from the idea of a creator when God's intent was to create science to lead you to Him. You know, sometimes things seem supernatural that we are able to explain later through, you know, science. Okay, I understand. But there are other things as well that are supernatural, that go beyond the natural, that we can only explain through believing in a creator. Right?
This is my big issue with science, scientific approach and non-scientific approach. You are absolutely right. In science, we are after the truth. And we are hoping by each day we're getting closer and closer to the truth. We never get there. Never.
Well, I know that's true for you. And
No, that's a science. That's you guys. You think you do have the truth. Now let's look at the evidences. As you were mentioning, you do have the conclusion, let's find the evidences. Science doesn't work that way.
That's not true. That is not true.
Well, you are saying
No.
you are referring to Jesus, who many billions of people do not believe, including myself.
And many more billions do.
So what?
So who's right?
So you investigate. That's the point. Argumentum ad populum. It's the fallacy of going, loads of people believe this, therefore it must be right. But they've acknowledged that loads of people believe different things. And when he's going, so how do we tell who's right? You investigate it. And I think he's completely wrong when he says that science is intentionally trying to divorce itself from the idea of a creator. I think it's more that science goes like, can we explain this within our material world? Let's investigate. Here's an example. So in 1802, William Paley said that if you were walking along and you found a watch on the ground, you'd pick it up and you'd say, wow, this is so complex and it clearly has a purpose. It tells the time and it's doing that very well. This must have a designer. Well, in the same way, you should look at the human eye and go, wow, it's so complex and it's got a purpose. It too must have a designer, a creator. At the time, he had no reason to think that something as complex as the human eye could have possibly come out of anything other than an intelligent mind. But then, half a century later, Charles Darwin publishes On the Origin of Species, laying out natural selection as the mechanism for evolution that essentially solves this problem. Through this mechanism, you can have some organisms that develop light-sensitive cells so they can distinguish light from dark, day from night, so they can avoid predators or orient towards the sun. And obviously, this is advantageous, so they're selected for, so they pass on these genes. Then maybe these light sensitive patches curve inwards and form a bit of a cup. Now that organism can detect the direction of the light. Now they've got better orientation towards light and dark, so they can identify prey and predators more easily. Then the cup deepens and it leaves essentially just a small opening, and that essentially acts like a pinhole camera. Now you don't just get direction of light and dark, you get shapes. And then transparent tissue forms over that and thickens into a lens. And now you've got clearer images and better depth perception. And now we've amassed so much information and so much understanding that we know exactly how you can go from just these little light patches to the complex human eyes that we have today. And you can see all of those stages in organisms now. You can see the light sensitive patches in single-celled euglena. You can see the eye cup in flatworms. You can see a pinhole camera eye in a chambered nautilus. Add a lens and then you've got the eye of an octopus. And so we went from being like, look at this doesn't make any sense to us, it must be God, to being like, okay, well now we've done all this science, we can say that we don't need God for this. It doesn't mean God doesn't exist and we didn't do this to push God away. It just means that we've found a naturalistic explanation for something that we observe in the world.
Of course I can.
When you say that we start with a conclusion and then try to match everything to make it work, like that to me is complete dishonesty. That is not true at all.
That is what you are doing
no,
right now.
No, you're not. You're making that assumption,
no,
which I think science does a lot of. Well, so do you make assumptions or not? Does science make assumptions? Does science make assumptions?
Yeah, sure.
Okay.
We do make assumptions based on things that are well supported and proven and reproven. We don't have
Show
to...
me how you isolate gravity. If gravity is an assumption, you show me in the scientific method how you isolate gravity.
We've done that actually.
See, again, great question, but it just demonstrates that she just doesn't have a modern, up-to-date understanding of what gravity is. Gravity is a description of how the universe behaves, but we're not even sure if it's a thing by itself or just a property of space-time. So what exactly does she mean by isolating it? Like, you can't just put gravity in a beaker. Here's an example of something she might be talking about though. This is called the Cavendish experiment. So these balls are all made out of lead. These smaller ones are on a horizontal bar with a torsion wire attached. Now there is going to be a small amount of gravitational attraction between these small lead balls and these big lead balls. By measuring the angle of the twist and knowing the masses and distances, Cavendish was able to calculate the gravitational constant G. Since then, scientists have obviously repeated the experiment a lot of times with better equipment, but the results came out very close to his original figure. But importantly, this bar would only twist if there was attraction between these balls. But I mean, that's just one example. I mean, we've detected gravitational waves. We've seen gravitational lensing. We can watch the planets orbit and they behave the way they do because of gravity. The tides are attracted to the ocean. We even predicted the presence of Neptune before we observed it because Uranus's orbit patterns weren't what we expected. Its orbit had small but consistent irregularities, like it was being tugged by something. Using Newton's law of gravitation, we worked backwards and said there must be a massive object about here. And within 1 degree of the predicted spot, we found Neptune. Again, great that she's got an inquiring mind and it's a fantastic question. But for whatever reason, she's either unwilling or unable to find it and understand the answers. And the most tragic thing of all is the answers are so cool, they're so interesting. And she's just completely missing out on them because of her worldview.
Yes.
You're like a round hard candy.
Conclusions require knowledge.
I just want to check in. How are you guys feeling? How's this discussion going?
I kind of feel like I want to develop some of this stuff a little bit more. It feels high level, but I feel like there's so much that I haven't really even touched base on.
Well, I mean, I certainly didn't think that anybody was on either side was going to flip.
Well, there's still time.
There's still time. I have hope for you, Wendell, and Shelley. I don't know about Dan. I have hope for you too. But, you know, it's certainly, I'm glad it's a civil discussion, certainly.
Oh, yeah.
Put your waters to the side, and we'll just do another round.
Hey, you want to say?
Good.
He flipped!
Can you imagine if they actually flipped midway? That'd be so good.
The greatest moment in television history right there.
Good.
All right. NASA is trustworthy.
So, I mean, obviously any organization can be wrong with certain things, and they may have individuals that lie or deceive or something, but as a general organization, they're looking for the truth.
Yeah, the idea that NASA and the government is lying to us about the shape of the Earth is the height of conspiracy theories. In order for this to be true, the literally hundreds of thousands of people who at some point over the last 50 or 60 years would had to be somewhat complicit in this, and nobody spills the beans at all, is on the face of it completely unbelievable.
Yeah, it's actually a shame that they didn't get someone from NASA to be sat on the scientist side. That would have been so interesting.
The private does not know what the general is doing. There's compartmentalization happening all the time.
Of course.
So it wouldn't be that far-fetched. Has the government ever lied to us is really the question at stake.
We all agree on that.
Yeah, but
Common ground.
Now we have NASA.gov, right? And absolutely, they're not lying about anything. They're completely transparent. Everything is true. We'd be foolish to
There's
think
a
that's
difference
true.
here. I'm sorry, this is a fallacy here. There's
Not
a
a fallacy.
I'm sure it is.
Go ahead.
You were talking about a government. Now you're talking about an agency of the government.
NASA.gov.
But this agency is scrutinized by thousands and thousands of scientists around the globe. You are dealing with smart people, believe me. You are dealing with smart people.
I don't deny that.
So it is very hard to do that. Once or twice, maybe. Not for the all time.
Yeah, I mean, it's so far-fetched, that alone. The number of people that would have to keep it a secret. The fact that no one has ever come forward and been like, hey, I used to work at NASA. We completely faked it. None of the photos are real. None of the Apollo missions were real. Even like the way they think that the moon landings were on a set in a Hollywood basement. All right, I wouldn't usually say this, but given this is a science video, that was a Red Hot Chili Peppers reference. But yeah, to think that it was fake and it was all done on a set or whatever, not one person came forward, not even like the person that did the running for the teas and the coffees. And the fact as well that like the government is notoriously bad at doing pretty much anything. Like it's inefficient, there are leaks, things get out, all of that. But somehow with the flat earth conspiracy, not only is one government in on it and is just doing a flawless job so far, all of the governments and all the space agencies all around the world are all in cahoots and no one knows about it. No one has any proof. No one's come out to say it. There's just speculation from flat earthers. It's like, at what point do you realize this is just totally unreasonable?
Raise your hand if you think we went to the moon.
What is the proof? Hundreds and hundreds of pounds of moon rocks and dust. And we have distributed those freely to PhD scientists around the world. And not one of those geologists has said, what is this?
Been proven to be fake.
And also and collected on the ice in Antarctica and in the Arctic as well. Those are collected. You don't have to go to the moon to get moon rocks.
Yeah, I mean, this is just straight up not true. You cannot get moon rocks from the Arctic. You can tell from their composition alone that they're moon rocks. For example, 98 to 99% of the crystalline material in lunar rocks is made up of only 4 minerals. That is not the case for rocks found on Earth. Also, because the moon hasn't got an atmosphere, tiny meteorites that would burn up if there was an atmosphere like there is on Earth are just constantly bombarding the lunar surface. That means that there are impact features and microstructures on lunar rocks that you just don't find on rocks on Earth. Also, obviously, you have the whole like competition with the Soviets argument, but the Soviet Union brought back their own lunar rocks and they confirmed the authenticity of the Apollo samples. They would want nothing more than to bring back rocks and be like, these Apollo samples aren't from the moon, we have proof. But they held their hands up and went, fair enough, they match our samples too. And like Spencer said, countless other scientists came to the exact same conclusion.
As a matter of fact, all U.S. Air Force photography prior to 1958 shows a flat Earth. Only NASA shows a sphere.
That is absolutely not true,
Jim. I wouldn't lie to you.
And the other
NASA's lying to you, my friend.
The other bit of proof
not myself.
is we have a laser retroreflector on the moon.
Yeah.
that we're using now.
We still use to this day.
It's sitting there.
You can find to the inch how far away the moon
No
is.
pictures of home.
That only is there. By the
No,
way,
there are not.
This is such whataboutism. Like they're literally saying there is a laser reflective panel on the moon that we still use today. And rather than addressing that in any way, he goes, well, no pictures of home. This is the innate human tribalism on show. He's experiencing cognitive dissonance. He's sitting there stressed out because he's hearing evidence that counters his worldview. And he knows he can't address it. He knows there's nothing he can say. He can fire a laser at the moon and it will bounce back off a reflective panel. That is proof beyond a shadow of a doubt that we've been to the moon. Okay, it doesn't necessarily prove that we went to the moon when we said we did, but not only do most flat earthers not believe that we went to the moon, they don't even think it's possible. They think it's a small, local, self-illuminating object. It's so bizarre.
Why? Why would all these honest, hardworking people perpetuate this massive fraud? Why would they do this?
What's the benefit of doing
Okay,
that?
the benefit of it. They make $52 million a day. Follow the money.
No, the little
Follow
guy.
the money.
The little guy.
That's what, then when you say all, okay?
But it didn't start out that way. And NASA was not founded to prove the Earth was a globe. It had nothing to do with the way they were founded.
Well, if you go and study
Are you sure?
Yeah, positive.
Really?
Yes.
I mean, the $52 million thing, like, as if NASA wouldn't have an equally large budget if the Earth was flat. It doesn't have to lie about the shape of the Earth. It would just have to lie about space existing, which is obviously another thing that they deny. The shape of the Earth is irrelevant to that money. It's all for things that we spoke about before. Technological advances, space exploration, scientific discoveries, climate, weather, and natural disaster observation and prevention. The shape of the Earth is the last thing that NASA would need to lie about to keep its budget.
Somebody has to be a voice for reason, and somebody has to be a voice for truth. It would be a fantasy to believe that I would change anybody's mind from the other three. However, if there's somebody sitting on the fence, and this is the first introduction to this debate, perhaps they'll hear the reasonable voice and say, yeah, that makes more sense than having this pizza-shaped Earth.
I can put myself in the mindset of the other side.
I used to be a ball earther. Everything you say right now is completely what I used to agree to. So I completely understand where you're coming from.
For me, I think the correct way to do any kind of investigation or to examine things is by literally putting yourself in that mindset of the other person. So I do that. I disagree with your position, but I completely understand from your perspective what you're saying.
The trouble I have understanding your perspective is, in the modern world, unless you live in a cave somewhere, you have to believe in science implicitly. I met a flat earther, a young woman who said, I don't trust anything that science does. And that's a problem because human beings can't replicate the whole body of science every single generation. At some point, you have to trust what's already been discovered and proven and move on to the next thing. Otherwise, we're not going to advance at all. I mean, when you turn that key ignition in your car, you expect the car to start out.
And not blow up.
And not blow up, because science puts you in that position. So it's really hard to understand how people would know in their hearts that science achieves wonderful things and then just jumping ship when it comes to this other issue.
We're not drawing conclusions. We understand the mechanisms that made that car work. There is no theories and no disputed conclusions involved there. It's not a good analogy. Can I admit a great compromise that we have to experience being against the grain people? Is we have to literally sit in a group and decide whether or not we can afford to have an opinion, and that's tough.
I agree with you there, because we're the same thing. I mean, I think skeptics go through this and atheists go through this. I don't believe in God. When I'm around religious people, I take a chance socially when I tell them I'm an atheist. So I know it takes some courage to follow your beliefs, and I appreciate that. But I think I've done a lot of research in that venue too. And it's not something I choose to believe in, it's something I have to believe in based on the evidence.
See, what I get from you guys is that seeing is believing. So how come you believe in God or Jesus? You haven't seen neither of them, right?
I've seen evidence, though.
Well, exactly. So we are looking for evidence. There are many, many other evidences for Earth not being flat. My point is that these experiments clearly show that the Earth is globe. And you don't need to go outside the globe to see it's globe.
It's a theoretical...
You told me you want the evidence. If you're saying that you look only to see something, then I dispute your belief system in God and Jesus or Jehovah or Buddha or Zarathustra or anyone.
You keep going back to religion as being
because
our
it's coming
conclusion.
from there.
No,
You think you do have the truth.
I have evidence. I have evidence.
You
for what
quoted
I
at the
know.
beginning
She
of
pointed out
this.
physics.
You quoted Bible.
Of
That's
course
the
I did,
reason.
but that is not the only reason I know what the shape of the Earth is, and you keep, that's fallacy.
This whole conversation is annoyingly meta. Like, they're speaking about evidence that they have and how much they weigh it and what priority they give to religion and science. But I wish they'd have deeper and longer discussions, or at least some discussion at all, about some of the science. I mean, we've had brief mentions of experiments and her going down to the beach and looking across the bay, but both of them are just arguing, going like, no, we've got evidence and there's compelling evidence and reasonable evidence. And it's like, they should start debating the evidence itself. It's all well and good both saying that you've got evidence, but if both of you disagree on the conclusions, you need to dive into the evidence and go, here's where your methodology's wrong, here's where your conclusion's wrong, here's where your calculations are wrong. Because both sides are sitting there going, we have evidence and it's reasonable to draw this conclusion from the evidence that we have that you're wrong. It just doesn't get us anywhere.
It's not fallacy.
It is a
Actually,
fallacy.
it is not fallacy.
It is a fallacy.
And then they pause before they even get anywhere and move on to the next section. I actually don't think this format works great for this kind of scientific debate. You almost need to say like, oh, you think that you can bring the bottom of a ship back into view by zooming in with a camera. Here's the camera. Let's go to the beach. There's a ship. I can see from this zoom in that the bottom half is missing. Zoom in, show me the bottom half now. Oh, let's go to this beach and look at the island across the water. Let's calculate how much curvature the bottom of that island should be hidden under. Then let's look at the angular size of the island compared with what it should be and see if it matches up with a flat earth or a curved earth. I'd love for them to just take them out and actually do the science and all of them sit there and go, wow, okay, these are the results, you know. We did 6 experiments. All of them produce results that are consistent with a round earth or maybe even a flat earth. But that I think would have been so much more interesting than this. But there's still time. And also, like I said, I'm able to add some of that information from home. So hopefully my ramblings are somewhat coherent and helpful.
I'm a theoretical physicist. What I'm doing is the combination of string theory and cosmology. So we try to understand what happened during the Big Bang, after the Big Bang, or even before the Big Bang.
What are you hoping to get from the discussion today?
Well, I hope I would be able, particularly to the young generation, to convince them that first, they should think critically and don't believe anything. They shouldn't take anything for granted. Look at the evidences and examine those evidences and throw away those claims that are not evidence-based.
Science, not to put it down, but when you're talking about rocket science, this is very difficult for the majority of people to understand, and it's designed that way. And so, in a lot of ways, hiding behind rocket science is similar to religion. If you look at the Catholic Church back in the days, only we can interpret the Bible, you have to listen to what we say. So in a lot of ways, we're getting that same notion from science that says, only we can interpret what these numbers are, you just need to trust us. But then when we actually do go and test some of their equations and they don't work, does that beg the question for us to go and test it ourselves? Absolutely.
Yeah, I mean, that's not what begging the question is, and that's also not what science does. They're not saying only we can interpret these numbers. A lot of academic peer-reviewed journals are public. The leading scientists in these fields aren't going, only we can interpret these numbers. First of all, most of their work will be published, a lot of it free. So you literally can read it yourself, you can scrutinize it, you can try and replicate the experiments if you're able to, and you can do your own. I think it's more that you haven't got the ability or the education or the training to be able to understand the numbers. And yeah, go out there, do the experiments yourself, but make sure the methodology is public, make sure the results are public, make sure no one can turn around and be like, we don't know if you factored in this, we don't know if you got this calculation right, we don't know if you were measuring properly. Put it all out there and then let people see, and then we can go from there.
I would say, one great thing about science is its predictability. Let's for a short moment, assume that your model, this flat earth model, is correct. I don't know, what does it buy for us? What does it predict for us? So my question for you guys would be, next time, bring me something from your theory, your model, that you can predict something which the globe Earth model cannot predict. Then I would change my mind.
I would just say that don't believe anything that I've said. You got to do your own research. And I think what you'll find is that you'll see that a puzzle piece doesn't fit. And the only way you're going to do that is if you put your own eyeballs on it.
Oh, I just wish he had said what those exact puzzle pieces were so the scientists could answer him.
I don't blame people for being skeptical. I'm skeptical about a lot of different things. I applaud that instinct in you. But you have to go beyond just not believing in something. Ask the hard questions. Ask what qualifies a YouTuber, a book author, anywhere else you're getting this information, what qualifies them to make wide-ranging comments about the shape of the Earth? Look, anybody who can overturn Einstein or some major theory is going to be eventually written in the halls of science for the rest of their lives. But they have to come up with the goods. They have to show good science-based evidence that what they say is true, and they have to withstand the test of time and peer review and the rigors of the scientific method.
All right, thank you. I'm all sweaty.
Ollie, it was nice to meet you.
I'll get a hug too.
Almost neighbor.
Very nice to meet you.
Thank you. Good seeing you. Hey, I want to get you a copy of my novel.
Oh, good job.
And,
Good job.
Yeah, I mean, that was just far less productive than it could have been. But I guess 6 people debating multiple different topics under this flat earth, globe earth umbrella in half an hour. Maybe I shouldn't have expected much. But still, there were some interesting viewpoints and definitely some cool opportunities to bring up some science. So hope you guys enjoyed those bits. This woman, by the way, is related to the flat earther in the other flat earth video I did. So if you haven't watched that yet, go check it out. The link to that will be in the description. Again, let me know if you enjoyed this sciencey type video. If you did and you haven't already, please feel free to subscribe down below. And hopefully I'll catch you on a video like this again very soon. And as always, thanks for watching. Bye.